So if you're anything like me, you're fascinated by video games, but it's easy to take for granted just how amazing they are. There's so much going on under the hood that we hardly ever think about. Behind the scenes are years of painstaking technical and artistic design. Even seemingly simple games are still built on generations of math and technology developments. Games give you the tools to make tangible worlds from the ground up, and have so many things to offer that no other medium really can because games are uniquely interactive. Like pretty much everyone my age, I've always wanted to make my own game, and have had a few attempts over the years to varying degrees of success. I think it's about time for another go, and I want to do things a little differently this time, so instead of using a pre-built engine designed for making games like Unity, Unreal, or Godot, for the past 4 months I've been making my own game engine using Blender as a base. I call it Blendworks, and it's a pretty big undertaking, so I'm breaking it into a multi-video series. Although I'm hundreds of hours into the project now, it's still very much in active development, and I'm excited about all the potential it has. I'll do my best to make this series as broad and interesting as possible, so even if you have no idea what Blender even is, I hope you'll still enjoy a deeper look at some of the magic behind games. I'll try not to get super deep into the weeds, so if you have any questions, don't be afraid to ask. Now, Blender is a lot of things. It's truly amazing software, but it's not a game engine, or at least it hasn't been for many years. Blender is used by game developers a lot since it's a modeling, texturing, and animation tool, but it's not meant to run games, so the things that game developers make in Blender are sent off to separate software. Recently though, Blender, and specifically Blender's Geometry Nodes tool, has become so robust that we can use it to make games. Now there are a lot of limitations since Blender wasn't designed to run games, so there are some challenges that will make things a bit more difficult. We'll work through those as we come to them though. Just so we're all on the same page, a game engine is a framework that games are built in. Usually they handle core parts of a game like rendering, physics, audio, user input, and that kind of thing. Just a quick introduction to geometry nodes as well. They're a feature of Blender that allow you to create and manipulate geometry by plugging nodes into other nodes. If you're familiar with my other videos, you have an idea of the kind of things you can do with them. So although we'll run into some obstacles by using Blender, we can also take advantage of the potential of Blender's many integrated systems, like geometry nodes, shader nodes, grease pencil, Eevee, and so on. So the goal here is to make the engine using geometry nodes for as many things as possible. Although a bit later on, I'll use some Python scripting with Blender's built-in scripting tool to handle keyboard and mouse input to interface with the nodes, just so it's not a total nightmare to control. A project like this is mostly for fun since there are a lot of problems with not using a dedicated engine, like optimization, save data, and exporting it as an application. That being said, there definitely are some practical applications, especially for prototyping if you already know your way around Blender. Also, most of the core concepts here are applicable to game engines as a whole. It's just the specific implementation that varies. In this video, we'll look at getting the core of our movement, but later we'll look at making things more robust with extra features, keyboard and mouse input, more complex gravity, and eventually turn it into a full-fledged game. One of my goals with this project is for it to be flexible enough so that you can use it too if you want to make your own game projects in Blender as well. I'll put the prototype files for each episode up on my Patreon. So where do we even start? I think a good beginning is the simulation zone, which is the geometry node that makes this whole thing possible. Basically, the simulation zone allows the result of one frame to influence the next one. A simple example would be this cube and this transform geometry node. We can move the cube with the transform geometry inputs, but you'll notice it does the transformation every frame. Even here we have the beginnings of a player. You notice that one problem we have is that our camera is fixed, so we can't follow the cube around with our view. Thankfully, there's a slightly goofy way we can parent the camera to a mesh, and as we control that mesh with geometry nodes, the camera will move and rotate along with it. We basically need to parent our camera to a triangle mesh, and now we can move that mesh and it will move with our camera. Now if we go to our camera view, we can move around in first person. We still have a big problem because if we try to use the transform geometry node to rotate, it rotates around the global origin, not our player's position. Plus, our movement is still relative to the global axis. So we're going to need a better way to define our direction and position. This is a good time to talk about one of the core principles of 3D graphics, vectors. The definition of a vector is a multidimensional quantity with magnitude and direction, but a vector simply put for our application defines a point or direction. Note that technically vectors and points are different, but they're both stored in the same way in Blender and are somewhat interchangeable. It just depends on how you use them. So most vectors that we're going to use have 3 numbers, one for each axis in 3D space, X, Y, and Z. In geometry nodes, anytime you see purple, it means that that input or output is working with vectors. For now, we'll use 2 vectors for our character, one to define the direction we are looking and one for our position. Let's take a look at our first vector, look direction. It's super helpful to visualize vectors with arrows. We can make an arrow that points from the origin to the direction we want to look using 3D coordinates. Our direction lets us define which way we should be moving. We can also use it to point our camera. To get a bit more technical for a second, I said earlier that vectors have both direction and magnitude. So direction is the point the vector is oriented to, but let's take a look at magnitude. Magnitude is basically the length of our arrow. We can have 2 arrows pointing the same direction, but give them different lengths. This is useful because we can use it to define something like the speed our character is moving, as well as our direction in the same vector. Sometimes we don't need the magnitude of a vector and just care about the direction, which is what it means when a vector is normalized, which is a term we'll come across a good bit when working with vectors. This just means that the length is always 1. So we preserve the direction without worrying about the length, and this makes vectors easier to use in a lot of cases. And now for our second vector, position. Our position is a point in 3D space. Essentially, our position is the point to which we move our player after we rotate. Let's take a look at the 2 values working together to control our player. Here you can see the 2 vector values updating as our player moves around. We'll see a lot more vectors throughout this project since vectors and vector math are essential for pretty much everything. The direction and strength of gravity and other forces, whether or not we're in a certain area or looking at a certain thing, calculating distances, collisions, and so much more. If we were building an engine from scratch, we'd need a lot more math with a lot more vectors to handle the core rendering of 3D objects. But since Blender already does that, thankfully we don't need to worry about it. Personally, it took some time before I was really able to understand vectors and how they work, so I made a tool to visualize vectors and help understand them better, specifically for Blender. If vectors are still confusing to you, or you prefer to learn in a more hands-on way, definitely go check it out. I'll leave a link to it in the description. Okay, so let's see how all this ties together with geometry nodes. I've condensed a player that has look direction and position into as small of a package as I could, and it uses around 10 nodes. We have 3 inputs, the camera geometry, which as we saw earlier is just the mesh that the camera is attached to. We also have forward, which controls the movement forward or backwards, and rotation, which rotates the player and changes the direction we look at. We need an initial camera direction that sets the way we're looking forward at first. I've picked the y-axis to be forward, which is somewhat arbitrary, but we'll need to stick with that decision for the rest of the project. We need to be able to change the way we're looking by rotating that vector. Vector rotation can get a bit complicated because there are so many ways to do it, and it's going to be one of the main challenges we'll face in this whole project. For now though, Blender has a vector rotate node, which makes things nice and easy for our simple setup. We need an axis to rotate around, which we can set as the z-axis because that's the up and down direction. We plug in the initial forward direction vector and our user rotation input. Note that we multiply the input rotation by -1 because rotation goes counterclockwise for positive numbers, and we want positive numbers to rotate clockwise so that when we move the slider to the right, the player looks to the right. Another math operation we can do to a vector is scale, which we can use to increase the magnitude or length of that vector. Scaling along the direction we are looking moves us forward or backward in that direction. And now for the fun part, our simulation zone allows us to iterate over the last frame as we saw earlier. We can plug in a point, which to start is 0, 0, 0, and then add our scale direction vector to change the position of that point to where you, the player, steer it. The simulation zone spits out the point that we can then use to set the position of our mesh that our camera is attached to. And now the last thing we need to do is rotate the camera mesh. We need to do this separately because we're rotating a mesh instead of a point. We need to isolate the rotation of that mesh to the z-axis, which can be done with a combine XYZ node. and now we have a simple player. There are definitely a lot of things we can add to give our player more capabilities, but it's a great start. We can start adding fancy stuff like collision and gravity in the next episode, so definitely subscribe so you don't miss that. Again, I'll put the project files up on my Patreon if you want to take a closer look or support the channel. Thanks so much for watching, and I look forward to seeing you in the next video.